So students, we have our next question. How many statements are correct for given complex CO C2O4 whole thrice minus 3? Means we can write this complex as COOX whole thrice minus 3. So we have to identify correct statement for this complex. First is, it has presence of negative ligand. Yes, it is correct because oxalate have minus 2 charge. So it will be a negative ligand. Means option number 1 is correct. Second option is, oxidation state of central atom is plus 2. If we identify oxidation state, then we take oxidation state of cobalt as X plus 3 into minus 2, oxidation state of oxalate, and it will be equal to minus 3, thus X will be plus 3. Means oxidation state of cobalt in this complex will be plus 3, not the plus 2. Means second option is not correct. Third, it is optically active. Basically, we can rewrite this complex as MAA whole thrice minus 3. And students, we know that all the octahedral complex having 3 or more than 3 bidentate ligands will be always optically active. Thus, this complex will be optically active. So statement third is correct. It is optically active. Now we come to statement number 4. Due to chelation in this complex, stability increases. So students, this option is also correct because oxalate is a chelating ligand. Means it form a ring with central metal, and if chelation in a complex is present, if ring formation takes place in a complex, then stability of complex increases. It is known as chelation effect. So statement 4 is also correct. Due to chelation in this complex, stability increases. Now we come to option number 5. It has 2 geometrical isomers. Basically, MA whole thrice complex does not show geometrical isomerism because we cannot change the position of ligands with respect to central metal. For example, if I make a geometry of MA whole thrice, then it will be like this. We can see that if we change the position of AA ligand, then relative change in position of ligand is not possible. Every time we will find A. Means at every position at 90 degree or at 180 degree we will find A after A. So MA whole thrice minus 3 complex will not show any type of geometrical isomerism. So geometrical isomerism is not shown by this complex. So option number 5 is incorrect. Now we come to option number 6. It is D2sp3 hybridized. Students, we know that oxalate is SFL ligand for cobalt plus 3. For cobalt plus 3, oxalate acts as a strong field ligand. Thus, this complex will be D2sp3 hybridized. All the electrons of cobalt plus 3 will be paired. Cobalt plus 3 have D6 electronic configuration. Thus, it will be D2sp3. So option number 6 is correct. Now we come to option number 7. If one oxalate ligand is replaced by glycinato, then it has 2 optically active isomers. So now we change the complex. It will be like MAA whole twice BC minus 2 because glycinato have minus 1 charge, unsymmetrical bidentate ligand. So it will be represented like BC. And oxalate is symmetrical bidentate, so we have write it like MAA. So complex will be MAA whole twice BC. Overall charge will be minus 2, but this charge does not affect the geometrical or optical isomerism. So we have to not look for this charge. Now we come to MAA whole twice BC complex basically. So we draw the structure of this complex. It will be like this. M, AA, AA and BC. So basically in this complex will not show any type of geometrical isomerism because if we change the position of B and C, then also every time we will find A at 90 degree, every time we will find a donor atom at 90 degree or 180 degree. So this complex will not show any type of geometrical isomerism, but this complex will be optically active. As I told you that any octahedral complex having 3 bidentate ligand, whether it is symmetrical or unsymmetrical, it will always show optical isomerism. So it will be optically active. And we also know that if one geometrical isomer is, if one form of a complex is optically active, then it will form 2 optically active isomers. One will be D and second one will be L, means dextro and levo. So this complex will be optically active. It will form 2 optically active isomers. One will be D and other one will be L. So basically point number 7 is also correct. So total correct options we have 5. Option number 1, option number 3, option number 4, option number 6, option number 7. So our answer will be 5. Total 5 statements are correct. Got it?